There are 5 properties of exponents: product, quotient, power of a power of negative, and power of 0. Let's check out where these properties come from and how to apply them. Here we have 3 terms, all with the same base of x, multiplying each other. So we're going to apply the product rule. Now to understand the product property, we're going to expand this expression out. X to the power of 4 is x times itself 4 times 3x times x 5 times. Now the 2 and the 3 get multiplied together like normal, so that equals 6. And then we have 10 total x's being multiplied together. So that's x to the power of 10. So the product rule is that when you're multiplying with the same base, you add the exponents. So we have 4, 1, and 5 add up to 10. Now this is also a multiplication problem with 2 different variables. So with our first variable x, we have x squared times x to the power of 4. So add the exponents, we get x to the power of 6. For our y's, we have 2 and 3. So that leaves us with y to the power of 5. Again, when you're multiplying the variables, you add their exponents. Now I like to use the phrase, when in doubt, expand it out. It's also a great way to check your answer. So we have x multiplying itself a total of 6 times now, so x to the power of 6, and y multiplying itself 5 times, so y to the power of 5. Now that we've applied the product property, let's look at the quotient rule. To figure out this property, let's expand this problem out. Now remember when you're dividing something by itself, it cancels out, or it equals 1, right? So x divided by x is just 1. They cancel out, and that's happening 4 times here. And that leaves us with just 3 x's in the numerator. So our final answer will be x cubed. So the rule for dividing is you subtract the exponents. 7 minus 4 is also 3. So let's try that without expanding it out. Now our 2 coefficients, 12 and 4 here, are not exponents. So we're not going to subtract those. We're going to divide those like normal. Now for our a's, we have 3 and a 1. So we have a squared. And then for our b's, we have 6 minus 5, which is 1. So we just have b to the power of 1, which is just b. And this is our final answer. But again, when in doubt, you can expand it out. I'd like to line them up so they're easier to cancel out. But we can see that we have 1 pair of a's cancel, 5 pairs of b's cancel, and that leaves us with 12 divided by 4, which is 3. And then we have 2 a's on the top and 1 b. Now what do we do when we have a power being raised to another power? Let's expand it out and see. This is currently our entire base, and it's being raised to the power of 3. So we're going to do x to the power of 4 3 times. At this point, you could apply the product rule and just add your exponents together, or we can keep expanding. And that's a total of 12 x's being multiplied together. So that's x to the power of 12 as our final answer. So anytime you have a power being raised to a higher power, you multiply them. So you just do 4 times 3, you get 12 a lot quicker. So let's try that again, just using the property. Here we have 2 terms being raised to the power of 5. We have x3 to the power of 5, so that's 3 times 5 is 15. And then we have y to the power of 5. Now there's just a 1 here, so we could do 1 times 5, which is just y to the power of 5. Look how much faster we got that answer. But we can still check by expanding it out. Here you can either apply the product rule and just add all your exponents, or we can keep expanding. And then add everything up for a total of 15 x's and 5 y's. A lot of extra work, but it gets you the same answer. So that's why these properties and these rules save us a lot of time. Up next, we have the 0 property. Any base raised to the power of 0 is equal to 1. Everything in here is being raised to the power of 0. So our answer here is just 1. Let me explain by using that 4 in the front. 4 to the power of 0 is 1. 4 to the power of 1 is 1 times 4. 4 to the power of 2 is 1 times 4 times 4. So there's actually always a 1 there. We just never use it because it doesn't change our answer. And we really don't get anything raised to the power of 0 a lot, but sometimes we do, and so it's important to remember that this exists. It's important to notice the difference here. This is not in parentheses, so that 3 is not being raised to the power of 0, just the x's. So really, we have 3 times x to the power of 0, which is 1. So this is an answer of 3. So your placement and the use of parentheses is really important. All of these were in parentheses, so they're all being raised to the power of 0. Only the x has the power of 0 here. Okay, our last and final property of exponents is negative power. A base raised to a negative exponent is equal to the reciprocal with a positive exponent. So here we have x to the power of negative 5. If we take the reciprocal of that, we get 1 over x to the power of positive 5. We flip it, that makes the negative exponent a positive one. Let's see this done in a more complex problem. The first thing I like to do is get rid of the negatives. So we're going to rewrite all these positives that aren't going to move. Now this y being raised to the power of negative 4, if we flip that and move it down to the denominator, it now becomes y to the power of positive 4. And this z to the power of negative 3, because it's already in the denominator, when we flip it, it's going to move to the numerator. So it comes up here as z to the power of positive 3. Now that all the exponents are positive, we can see if we can combine any of them. Now, unfortunately, all 3 of them are different bases, so none of them can actually be combined. However, we still have the 2/8 out in front, so we can simplify those like normal. 2/8 reduces to 1/4. So we just have x squared z to the power of 3 over 4 y to the power of 4. And those are our 5 properties of exponents explained. I hope it helps.